Thank you. Okay. Let's just take the equation. Two x plus 3y equals 7. 5x minus, what is it, 4y? 2y equals 4. Okay. We can graph this equation and we can graph this equation. I'm not going to go back over how to graph linear equations. I'll just say what I'm doing. We've got limited time here. You folks kind of, yes, you know, we did graphing linear equations a long time ago. Okay, you might have to review it, but it's very simple. Okay, so what's the? I'm going to change one of these numbers so you can answer by holding up fingers. I'll change this number too. Okay. What's the x-intercept of this first equation? Can you tell me, Quentin? Haven't seen anything yet. Hold up fingers if you got it. Okay. What do you know about the x-intercept? It occurs when y is 0. X-intercept is on the x-axis. It occurs when y equals 0. That's true of any equation, including the polynomials and rational functions that we've dealt with. Okay, I got an answer, and it's actually the y-intercept is correct. Okay, the x-intercept occurs when y is 0, right? If y is 0, you get 2x equals 12, so x equals 6. So again, you need to know that, review it if you have to. And as I was saying, the y-intercept occurs when x equals 0. The x-intercept occurs when y equals 0. We use that graphing polynomials, rational functions. Okay, it's a concept that you apply again and again. So if it didn't all of a sudden become brilliantly clear to you when I said that, get a little more brilliant. Okay. In other words, make sure you really understand what we mean by x-intercepts and y-intercepts and how you find them. Y-intercepts are generally, for any function, they're really easy to find. You just plug in x equals 0. Okay. X-intercepts, you got to plug in y equals 0, and sometimes you got to do some work. But you have to get used to the idea. What do we do with intercepts when we graph polynomials? Review that and see that we're talking about the same thing, just with different functions. Okay, well, anyhow, there we have it. So here's the point. Here's the point 0.06. Yeah, I do that a lot. So keep an eye on it. 60. And we have up here the point 0.4. That's the y-intercept. Here's the graph of y, 2x plus 4y equals 12. Now, which intercept can you, well, I actually don't have enough fingers. That's all right. Everybody's got 10, at most 11 fingers, right? Okay, some people have 6 fingers on one hand. Some people actually have 6 fingers in 2 hands. And if you did, you'd kind of be able to tell me what the x-intercept is, okay? Because of the y-intercept, I'm sorry. If x is 0, y would be -12, right? So, okay, well, that means that we got, bring the graph way down here. If that's 4, 4, 8, 12, way down here, okay. So here is 0, -12, that's our x-intercept. Our y-intercept, our x-intercept occurs from y equals 0. If y is 0, 5x equals 24, so x equals 24 divided by 5, which is a little less than 5, it's 4/5. So if that's 6, let's say here's I'm kind of close to 5. So now we our best approximation of a straight line, and the two lines intersect here. Now, we don't have an abundance of time, but I want you to take just a minute, see if you can write down the coordinates that you estimate for this point. If I were to draw the graph, just ballpark, I've got enough scaling on this graph that you can kind of give me a ballpark figure of what the x and y coordinate of this point would be. So just kind of don't try to be too accurate. Remember, you're using my graph, and I've discredited myself on graphs today. Half-life of 14, duh. Okay. See what you think. And you can draw a more accurate graph than I can. My x-intercept would be this x coordinate, which looks like a little more than 5. If that was 5, pretty close to 5. Okay, the y-intercept, or the y coordinate, would be this. If this is 4, this is 2, that's a little less than 1. Okay, so maybe close to 5, 1. Okay, the intersection point here. I think maybe a little less than 1, and still pretty close to 5. Now, if x is 5 and y is 1, what do you get here? If x is 5, 2x is what? 10, right? And if y is 1, 3y is 3. 10 and 3 is 13, which is pretty close to 12. So 5, 1 seems to work pretty well for the first equation, right? How about here? 5 times 5 is 25, right? And 2 times 1 is 2. It'd be 25 minus 2 would be 23. Okay? So these are close. So if you draw a decent graph of two equations, you can tell approximately what the solution ought to be, so that when you then do the elimination process that I'm going to illustrate here in the last 5 minutes, okay, you'll be okay with it. Now, your book is going to give you plenty of introduction. You should have seen it in prerequisite courses. And it's not too hard when you have two equations and two unknowns. Okay, so here I'm going to write my equations down again. And that's actually well, okay. So now we're going to say I've got 2x plus 3y equals 12, and 5x minus 2y equals 24. I'm going to call this equation 1. I'm going to call this equation 2. Now I'm going to write down leave myself room. Need a little more room. So I'm gonna write down 5 times equation 1 and minus 2 times equation 2. You might see why I'm doing this, and you might not, but it's pretty easy to understand. Okay. So 5 times this equation, 5 times 2 is 10, so that's 10x. 5 times 3 is 15, so we got 15y. 5 times 12 is 60. Then we do minus 2 times this equation, which gives us negative 2 times 5 is negative 10. So we got negative 10x plus 4y equals negative 48. Okay. So now this will be my new equation 1. This will be my new equation 2. So the new equation 1 is 5 times of my old equation 1. My new equation 2 is negative 2 times my old equation 2. Okay. Now what do I get if I add? My new equation 1 to my new equation 2. So the circle 1 and the circle 2 now refer back to equations 1 and 2 in the previous step. Okay. So if I add this equation to this equation, write down what you get. Actually, we don't have time. But you can easily see that equation. Well, what's 10x and negative 10x? Show me with your fingers. Who's like, no, right, 0. Okay. Now, 15y and 4y, we don't have enough fingers. You know what, you take off your shoes. Okay. It's 19y. And that equals 60 and negative 48, which is 12. So now y equals 12 over 19. Okay, now how does that agree with my estimate? I estimated the y coordinate of 1, right? 12 over 19 is about 0.6 something, right? Okay. So it's a little less than 1. I said I thought it was a little less than 1 because naturally I'm always right. Okay. And now I plug that back in. Okay, so I plug this back into, let's say, my first equation, doesn't matter where. And I'm going to come over here because I don't have room below. And now I've got 2x plus 3 times 12/19 equals 12. Well, that's easy to solve for x. That's a little messy. I've got to multiply both sides by 19. So I get 38x plus 36. And 19 times 12 is 228, I think. So that 38x, if I subtract 36 from both sides, I get 192. So x is 192 over 38. Now 5 times 38 is 190. So 192 over 38 is like 5 and 1/19, which is really close to 5, isn't it? So if I make this 5 just a little bigger and shrink that 1 down just a little bit, these numbers will match up. I won't get 13 equals 12, I'll get 12 equals 12. I won't get 23 equals 24, I'll get 24 equals 24. And I will have found an x and a y that satisfy both of these equations. Now, open math is going to run you through, but it's a pretty simple process, but you really want to get it down because then Tuesday we deal with 3 equations and 3 unknowns. Okay, then you might want to even look ahead a little bit on that. It's a little more complicated, but if you get this down, it's not bad. You got 3 equations and 3 unknowns. You eliminate a variable. Now you got 2 equations and 2 unknowns, and you do this. Okay.